Hello, we are in Chapter 6, Section 6.4, Equations Quadratic in Form. In this video, we are going to go over problem number 5, in which we are to solve this equation using U substitution. In U substitution, we always search for building blocks that appear in the first and second power in our equation. It looks like in here they are nicely shown to us in parentheses, because the 5p plus 2 is in here in the power of 1 and in here in the power of 2. So if we let u be equal to 5p plus 2, then this is our dictionary, and our u equation will be 10u squared minus 11u minus 6 equals 0. Now we just have to solve that equation for u. We acknowledge that this is factorable since the number negative 60, which is the product of 10 and negative 6, can be presented as the product of two numbers that add to negative 11 as negative 15 and positive 4. So we can split our middle term into minus 15u and plus 4u. Rewriting everything else as is, 10u squared minus 6 equals 0. We then continue with factoring by grouping. In the first group, the common factor is 5u, and after factoring it out, it leaves us with 2u minus 3. So for our grouping to be successful, we also want to see 2u minus 3 as a factor in the second group, and we can achieve that by factoring out 2 in here. Still equals 0. And now with the common factor of 2u minus 3, when we factor it out, it leaves us with 5u plus 2 equals 0, of course. Now we use the zero factor property. 2u minus 3 equals 0. Or 5u plus 2 equals 0. Then solving that first equation for u, we add 3 to both sides first to get 2u equals 3. And then we divide both sides by 2 to get u equals 3 halves. And in the second equation, we start with subtracting 2 from both sides to get 5u equals negative 2. And then we divide both sides by 5 to get u equals negative 2/5. Those are obviously our u solutions. We have to translate it back into the language of the original variable, which is p in this example. So every occurrence of u in these statements stating the u solutions, we replace u with 5p plus 2. So we really have 5p plus 2 equals 3 halves. And 5p plus 2 equals negative 2/5. Now it's just the matter of solving these two equations for p. Let me switch up here with those. In the first equation, we can start with subtracting 2 from both sides. Of course, in here we want to perceive that 2 as 4 over 2, so that we can combine those fractions nicely. So that will give us 5p equals 3 minus 4 is negative 1/2. And then we divide both sides by 5 or multiply by 1/5. So on the left, I will write it this way. On the right, I will write it that way. So it's easier to multiply the fractions. And that will lead to p equals negative 1/10. In the second equation, we also start with subtracting 2 from both sides, but this time I want to perceive the 2 on the right-hand side as 10 over 5. So that will give me 5p equals negative 12/5. And then we divide both sides by 5 or multiply by 1/5 again. So over 5 in here and multiply by 1/5 in there. That results in p equals negative 12 25ths. And these will be our 2p solutions. That means solutions in terms of the original variable of our equation. There is always or between them. And that's gonna be it. As always, I encourage you to plug those into the original equation to check if they really work.